That was actually quite a bit longer than just a minute. But I think that I've come up with an outline for this Marshall thing. No. Okay, now, first thing is I just defined this type. It doesn't say anything except that it's a way of distinguishing a T from a Marshall T, essentially. Whether or not the creation of one of these things is going to work with my auto creating thingamajig is another story, but let me just give you a lowdown. So first here we have this real math, which is a reference counted pointer to an interface real math. Now in order to do the Marshall trick, just like before, I invented a struct called a type of function call, a real math function call, which has a signal in it that is to be waited on. MR means manual reset, so it's S means settable. It's a settable manual reset object. It can be set once, and it's like a one-way bool. Essentially, it's the one-way bool. Okay, it starts out in the unset state, obviously, or else what will be the point? To signal that the operation has completed, one calls this function, which sets the signal that somebody might be waiting on using this function, wait. Okay, now maybe that should just be infinite, but I put a timer. Now the functions that need to be overridden in this case are invoke, call the function, and retrieve the result. This thing would be called after this wait is completed. So this would be called in one thread, and this would be called in a different thread. All right. Now I just threw my queue, the thing that I just made up, in here. I have to put it into a standard area. But for a quick hack to get the idea, put it in here. I grabbed that from this queue project I was looking at before. We made the queue go, and it's totally thread safe, and it's one way of handling messages, sending messages across threads. Alright, so it's the same code as before. This is the function that would be called to dequeue a message in the marshalling thread, although I didn't set that up. Now here I've defined one particular type of real math func call. It's a binary operation which takes two references to doubles and a return double star and returns a bool success. It contains within it a pointer to a iRealMath, two double values, a place for the result value, and a boolean for the success value. So the invoke call simply calls pf, whatever is supplied, with the two values and stores that in the result, and signal the operation is complete. At that point, there's no more touching of these, so everything's safe. The result function simply waits for the operation to become complete, and if success occurred, the value here is stored in this pointer, the resulting value, and the success, whatever it was, is returned. To initialize, you pass in a real math and two doubles. That could be constant references, I suppose. Doesn't make any difference. In fact, this reference idea is not it's not much help, because you still need to store a full double in the structure, right? But anyway, just for consistency, I'll make those references. So here now is my marshaled math, which only implements one function. Turns out, in a marshaled sense, it implements all the functions so that it would compile. These I just grabbed quickly just to see if I could make it compile. It has its queue, right? And I'm not doing anything yet, but here would be where I would put the wait call. So just like in that other project, whatever it is, I can just copy this code, the waiting code. Okay, this is it here. Now this is a string for some reason. Oh, there was a queue of strings, but in this case it's a queue of func calls, pointers to, right? So what I need to have here is a container for that. P call, let's say, and then just put that here. So this thing wait any DQ waits on either this second signal going off, or if the queue becomes signaled, in which case there's a message waiting, we want to dequeue it. So this is all in one step, which is a little bit more efficient. Now, let's see now. We're waiting on the signal for so many seconds. And it's hidden, right? This thing here derives from semaphore. So it's really semaphore dot wait any. So if the reason is self-signaled, that means that the semaphore is signaled, not the quit thing. This is a quit signal. In which case we dequeue a message. Dequeue is a mutex protection thing. Now you might think that there's a danger here that this thing here gets signaled, and what if in the meantime, before we get here, somebody jumps in and dequeues our message, another thread, right? Well, that can't happen in general. In our case, it can't happen because there's only one thread. But in general, if there are thousands of threads waiting, on the same queue, for every thread that's allowed through this wait, right, a message will have been placed on the queue to be dequeued. So even though the one that caused this wait to terminate may not be the one that gets DQ'd. There will be one DQ'd. There will be one message for every single thread that is allowed through. Only as many threads get through these waits as are messages ready to be DQ'd. So, if there was one, and by the time I get through to here, 10 more got in, then there will be 11 messages to DQ, and I'll definitely get one of them. And I'll get it in a thread safe way. Alright, so now in this case, the thing DQ'd is a pointer to one of these front calls, right? So now what we do is we call, we don't do this, and we don't do this. We say p call invoke, right? And that's it. And then we return back to our loop. Invoke, in the case of the adder, here's the add function. I create an adder function called object, which uses the iRealMath function add, takes as its argument a pointer to the object that we're using, that I created, and two double references, two doubles happen to be references, but they get copied into the structure. I put that p adder on the queue and wait, and return result. Result here involves a wait. When that thing finally gets DQ'd and invoke gets called, invoke will signal that the operation is complete according to this template, and my wait will satisfy, and I can check this is all thread safe. In fact, you could assert here. You can't assert it really. No, I can't. Can I? No, I can't. I can't assert that the thread has died. Although, now, why is this not ambiguous? Oh, because it's a phone call. This here wait is waiting on this signal that's in here. Right. The thread might still be running, right? Even though it's just dying, getting ready to die after the invoke. Oh, no, sorry, the thread's constantly running. Never mind what I just said. This here invoke gets called within the EQing thread. This here wait is being called from some other thread, but none of these variables are going to be touched after that signal has been set, right? Because the invoke is completed. And invoke is the only interface. The thing that's called after the invoke is done, the thing continues waiting, and that's the function. So I just return result. Oh, but I gotta delete the adder. Actually, I've got to get a result. Now, can I delete this after? Oh, very nice if I could. Well, return value is that. Delete p adder. Return b red. I could probably do that all in one step with an auto, an auto deleting thing. I could make for this adder. The adder is not one of my COM things. It doesn't have a reference count or anything. It's just a a pointer to one of these objects. A function call. So that's add. Now sub I can do in exactly the same way. Right? It's going to look kind of stupidly similar. You'll have to, turn this into another template. Template function for binary ops. They're all going to look exactly the same. Why don't I just make it number defined? Name. Func call p name is new real math name in Q a function call get the result, delete the function call, return the result. Make sure that that's okay. So if that's correct, oops. So see if that compiles. Oops. Probably won't. But once it's ready, it'll be easier. I haven't complained yet. I think that's the first time I've ever done that successfully. Now it looks like I can, even further macroify this because like mul and mul here match, right? Never mind. Do that later. Okay, now this is a binary operator. It turns out, but it returns a bool. Okay. And oh no, it's a pointer to int. So I can't do that one just yet. It should compile, and we should be able to do these ones. Marshall. Put this away out of sight. Here at the top. I usually put macros way up top for some reason. It's become a habit. Now the question is, what's this function name going to be? Like, if I request this type of object, is it going to work? That's the burning question in my mind. And I've already written it down, in fact. Let's see what happens. I doubt it's gonna work first shot, but who knows? That's a name, right? That's just sort of a name decorator. Let's see what happens. It should ask me for a DLL again, but I can give the same DLL. Let's see. Create device, Marshall, blah blah blah. That doesn't look completely wrong. Scope. Sphere dev name iRealMath bracket. Let's see. Because I'm not being in trying to determine the name for the registry key, which is this thing. What do I want for the name? I want it to say TS Marshall scope. It's almost right. It is a TS. It should be TS device Marshall. TS device Marshall. And then the thing in brackets. Anyway, press on. Doesn't matter if it's a stupid name, as long as it's different. Although if I use the same trick again with a different type, I'm gonna get the same string back. And that's no good, right? This is not a good dev name. Still, output decorated name is that. Two functions are exported. It looks right. It's got that question mark, dollar, blah blah blah. The only way to be sure. Let's see if we should copy it in. Okay. And then copy this. Okay. Back here. Looks the same. Marshall, all that stuff looks. The second one is the previous non-Marshall. So it works. we got the right function name. The function name's correct, and that's going to work. However, we didn't really get a very good device name out of this. I could just use the, not try to figure out the scope or anything, just use it as is. Whatever this thing comes out to, generally speaking. Let's see, what is it initially? You can use anything in the registry for names. What's wrong with that? That's a pretty good name for an object, right? It's very precise. And you know, I wanted it to be pretty for the non. But, oh, for the other case, where's debug? Dynamic debug F5 devices real math W. I put that W and A. Okay. Alright. Now, do I need W and A? Probably. So suppose I just called this dev name. Don't muck around. Go back to the initial test. Okay, just a real math star. So what? Nobody sees the register. I mean, it's better than those UUIDs, right? I mean, that's that. Okay, here goes. First test is does it work in the old sense? No, this trace line says that that's what my device is called. Bool. Oh no, bool whatever. This. What is this? Oh, I haven't created it yet. Okay, no problem. That's a perfectly fine name for a real math. Now let's go back to the unit test. Let's locate the same DLL, no problem. Should work fine. That's the same. Okay, so something changed in the registry. It doesn't look like that. Now, what about a Marshall? It should find the correct function and return the correct object, and when I make a call, it's going to switch threads to the marshalling thread. If I actually start that thread going, where can I do that? Well, after I create it, I can start it. Create the device. See, this actually creates a real math. which is a member. No, well, I can just do start. And when it deletes itself, it'll have to stop. I don't think I need it. It's the thread thing. It will stop itself on delete. I think that should work. That starts the thread going. This thing. And it will quit if we ask it to quit. Asking it to quit is the same as calling a stop. All that stop does is set a signal and wait. Breakpoints here, 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 and here. Now let's see what happens. Okay, so that's my funny name this time. That's the device name. So here's the registry key for a Marshall real math. Turns out it's going to be the same DLL. I'm going to choose the same DLL. And it should find the function. Computed the name correctly last time. Here it is. Now, this is calling create device for a regular real math. And that puts me here. It creates a regular real math. And also should start the thread. All these extra ones from that stupid dialogue. Okay, here we are. Thread is started. And now it's going to sit here and wait to get invoked. I'm going to go back here. Now that thread is still running somewhere. Which one is it? Not that. That? This one. No. I don't know which one it is. Over here. No. Not sure. Add. What did I just press? Oh, maybe it doesn't have the. Okay, it didn't build the debug information right. Here's the function. Oh, invoke got called. Now, it must have gone through this add already, because the only way something got on the queue would have been through this thing, but I must have pressed the wrong button. I'll get it next time. Invoke. What's in pcall here? Those are the numbers, certainly same, right? Now here, it's going to call the function, whatever the template parameter was, ps, which is the adding function for myRealMath, which completes successfully. These successes true. Now the operation should be complete, and somebody is waiting here for a result. Right? This line should eventually get hit, and it does, in a different thread. This is the thread, the calling thread, right? Here, binary op that we didn't see, which called add directly from here, switch threads, addition occurred, and now it's a matter of using the macro collects the results for us. The return value and the pointer to result is passed in to the result function, which is, well, we're in it. If B success, and it was, store the result. Okay, 9 something. Return success, if not, or whatever. It was a success. The addition occurred, and a marshaled addition happened. We release the object. Oh, now we're going to have a memory leak because we're only releasing one object. So here's our memory leak. So that's the reason for that is our marshaller was the marshaled math, not binary out, has to release pmath after calling stop, because while the thread is running, this thing might be accessed. But after calling stop, it's safe to release it. So the next time I run it, we shouldn't get a memory leak because this guy gets released. And now what about add ref and stuff like that? It doesn't matter. This is like this is very similar to whatchamacallit, the thing that I've been struggling over for ages. Aggregation, right? We don't need to increase references on this member because we've got our own reference count, and when we die, it dies with us. So there's no need to modify the reference count of the contained object. Now this time it should have no memory. There is no memory. The add works as normal, but it didn't happen in the thread that called the function. And there you go. That's marshalling in a nutshell. Haven't done the unaries and I haven't done these functions, but I'll do them and try and think of a more general way. This is getting close to an elegant solution. and we'll see you. See you.